All right, gentlemen, this is the very last question from the worksheet that you got last week. Um, in part one of the question, you asked, first of all, find the derivative of this fraction here. How do you find the derivative of a fraction 1 minus x over 1 plus x? Right, you may recall that we use the quotient rule to derive fractions of this nature. So this is given by v du minus u dv divided by v squared. Right, my v there is 1 plus x and my du is minus 1. So it becomes minus 1 multiplied by 1 plus x minus my u is 1 minus x and my dv is 1. So it's 1 multiplied by u is 1 minus x, and this is all over v squared. V squared is 1 plus x all squared. Right, so if you just simplify the numerator, you will get minus 2 all over 1 plus x all squared. All right, but we now asked to find dy dx. Right, my original function y is given in power notation as 1 minus x over 1 plus x all to the power of a half. Now, to find dy dx here, you will know from your AS that dy dx is given by, you bring down the power, so this becomes a half. 1 minus x over 1 plus x, and minus 1 from the power becomes minus a half here times the derivative of the gut. The derivative of the gut is exactly what we found in part 1, so this becomes minus 2 over 1 plus x all squared. And if we simplify this thing here, this becomes, and flip this fraction. If we flip this fraction here, the power becomes positive. So this now, and this 2 here and this 2, they cross cancel. So you'll have minus, open bracket, 1 plus x to the power of a half divided by 1 minus x to the power of positive a half. This is multiplied by 1 over 1 plus x all squared. Right, so this here is the gradient of the tangent at any arbitrary point xy. Now, we are required specifically now to find is given by dy dx is equals to that. But the gradient of the normal, remember, is the negative reciprocal of this whole function here. So what will be the negative reciprocal of this? This will be 1 plus x all squared times 1 minus x to the power of a half divided by 1 plus x to the power of a half. Could have simplified this here, these two here in this question, but I chose not to do that, which is fine. So if you simplify this now becomes, these two here, they've got the same base. What do you do to the powers? If they're dividing, you subtract the powers. So this becomes 1 plus x to the power of 1 and a half. 1 and a half, which is just 3 over 2 multiplied by 1 minus x to the power of a half. This now becomes right, because it's a tricky question. It's a show question, so that means that we require to show that the gradient of that normal there is 1 plus x multiplied square root of 1 minus x squared. Right, so we have to do a bit of juggling here. Now, if I'm to separate this, watch what happens. So I've got 1 plus x, all right, to the power of 1, which is exactly that. So if I split that, that means that the other one will be 1 plus x to the power of a half. A half, and this one here, it gives me 1 and a half, which is 3 over 2. Multiply by 1 minus x to the power of a half. This now becomes 1 plus x multiplied by 1 plus x multiplying 1 minus x, all to the power of a half. Right, this here now simplifies to become a difference of two squares, which is equals to 1 plus x multiplied by the square root of 1 minus x squared, which is basically the answer that we are required to show. All right,